So, hello everyone. Today we'll be covering the topic salts. More about salts. We already know how salts are formed. There are various ways to form a salt, as we already read previously. That an acid plus metal will form a salt. A metal carbonate plus acid will form a salt. And metallic oxide plus acid will form a salt. And obviously, all acids and bases will form a salt. Right? Acid plus base reactions will form a salt. So pH of salts. Now what is the pH of a salt, right? The pH value of the hydronium ion concentration value of a salt. So salts of a strong acid and a strong base are neutral and they have a pH value of 7, right? So they have a pH value of 7 and they are considered as neutral, and they are the salts formed from the reaction between a strong acid and a strong base. Now, what are the chemicals formed through common salt? Salt formed by the combination of hydrochloric acid HCl and sodium hydroxide NaOH. Solution is called sodium chloride. So HCl, that is hydrochloric acid. I think we read it somewhere previously too. Hydrochloric acid reaction. I don't know if we read it or not. See, this is sodium NaCl. Well, let's just skip it right now. So this is sodium hydroxide plus HCl, hydrochloric acid. And what was in there? I think it was the same. Hydrochloric acid and sodium hydroxide solution. This is hydroxide. So it forms sodium chloride. Now this is the salt that you use in food. So the salt that you use in common food or while baking, cooking, it's sodium chloride, that is NaCl. And how is it formed? It is formed through the reaction between an acid and a base, and in particular the acid hydrochloric acid and the base sodium hydroxide. And this is a neutral salt. Now seawater contains many kinds of salt dissolved in it. Sodium chloride is separated from these salts, right? Deposits of solid salt are also found in several parts of the world. These large crystals are often brown due to impurities, that is your rock salt. This is called rock salt, Sindha Namak. Beds of rock salt were formed when seas of bygone ages dried up. Rock salt is mined like a coal. This is not important. Let's move on. You just needed a quick study of it, right? So common salt raw material for chemicals. The common salt thus obtained is an important raw material for various materials of daily use such as sodium hydroxide, baking soda, washing soda, bleaching powder and many more. In these kind of substances, the common salt is used. The common salt is used to make sodium hydroxide, baking soda, washing soda, bleaching powder and many more, and these are very important products. Now we'll learn how these products are actually formed. So in consideration of sodium hydroxide, how is sodium hydroxide formed? Sodium hydroxide is formed when electricity is passed through an aqueous solution of sodium chloride. It means that when you create an aqueous solution of this common salt and you pass electricity through it, it will decompose and it will form your sodium hydroxide. Okay, sodium, hydrogen and oxygen combined, that is sodium hydroxide. Then this process is called chloralkali process because of the products formed. Chlor for chlorine and alkali for sodium hydroxide. Okay, in short, when you pass electricity through an aqueous solution of common salt or sodium chloride, it will decompose to form sodium hydroxide. And chlorine gas. The main component here is sodium hydroxide, but it will also release chlorine gas and hydrogen gas. It will release these two things also, that is chlorine gas and hydrogen gas. So three products are released: sodium hydroxide, chlorine gas and hydrogen gas. Chlorine gas is gonna at the end, this is not important again, but you should read it. This might come in exam, though in real life this is of no importance. Okay, so let's move on to the second experiment. The second product, bleaching powder. We have already come to know that chlorine is produced. Now we already know that chlorine was produced during the reaction between electricity and sodium chloride, right? When we passed electricity through sodium chloride, sodium hydroxide was formed, and along with sodium hydroxide, chlorine gas was also formed. Chlorine is produced during the electrolysis of aqueous sodium chloride. Aqueous sodium chloride is also called brine. This chlorine gas is used for the manufacture of bleaching powder. Now the chlorine gas is used for the manufacture of bleaching powder. Bleaching powder is a product by the action of chlorine on dry slaked lime, calcium hydroxide. So when you spread, or when you react chlorine gas with dry slaked lime, bleaching powder forms out as a result. Bleaching powder is represented as CaOCl, calcium oxygen dichloride, CaOCl2. So I call it calcium oxygen dichloride. Dichloride means two chlorine atoms, though the actual composition is quite complex. So the actual composition is a little bit complex, but we'll learn the simplified version in here. So this is calcium hydroxide. Wherever there is OH, it's hydroxide. Ca for calcium, OH for hydroxide. Then this calcium hydroxide plus what? Plus chlorine, right? Chlorine would be always at Cl2. Then what would it form? It would form calcium, would come right out here as calcium as it is. O would also be attached here. O would remain the same, CaO. Then Cl2. This Cl2 will come and combine with Ca, right? And H would be taken away from it. H would be taken away. So what would it become? It would become, and obviously H cannot remain in a free state. H needs to combine with molecules of oxygen, and then it will form water. So the product would be calcium oxygen dichloride plus water plus H2O. CaOCl2 plus H2O. You can easily remember this reaction. Ca will remain in its place, it will be the same. O will also remain here. H will go, because H always needs to go, because hydrogen ions will be released when there is an interaction. When hydrogen ions are part of the acid, right? Hydrogen ions will always be released. So hydrogen is gone from here. Then this Cl2 will come to this side. It will combine with them, and H will go to other side, and H will combine with what? Oxygen atoms, and H plus oxygen atoms will make what? Water, that is H2O, right? So this is the reaction as to how bleaching powder is formed, and this CaOCl2 is called your bleaching powder. Now these are some uses of the bleaching powder, and the most important of them is for disinfecting drinking water to make it free of germs, though it's better if you remember the other two uses too. Now baking soda. Baking soda is a very important substance, is a very important ingredient for making lots of food products. For example, your chips, your pakoras, these are made through baking soda. Soda commonly used in kitchen. Sometimes it is added for faster cooking also. The chemical name of the compound is sodium hydrogen carbonate. So baking soda is chemically called, or in science baking soda is called sodium hydrogen carbonate. Now you must have noticed that there is always this sodium. Sodium is there, why? Because it is a salt or a product of salt. So wherever there is salt involved, sodium will always be there, right? So see, this contains Na means there is salt in here. So sodium hydrogen carbonate, see, it is formed through, because these all the products, this baking soda, bleaching powder, sodium hydroxide, all these are formed through salt. So they would always contain salt, and that is why they would always contain sodium. Sodium is equal to salt. It is produced using sodium chloride. Now sodium chloride is your natural salt, the salt that you use in food, the one we previously read just now, that's sodium chloride as one of the raw materials. So we know that all of these will be formed through sodium chloride. So you can just, as it is, write sodium chloride right here, NaCl, plus this is water, H2O, plus CO2 carbon dioxide, plus NH3. Now what is NH3? Here it is NH3. NH3 is ammonia. Okay, the only different thing in this reaction is ammonia. Rest all we have read before somewhere at least. NaCl plus H2O plus CO2, right? NaCl plus H2O plus CO2. Where did you read it? Just try to recall it. I'll show you that we have read this before. Na2CO2. Here you see, here carbon dioxide is where it was, carbon dioxide somewhere. I think it was here. So here it is NaCl, that is sodium chloride, plus H2O plus CO2, right? It's the same reaction, exact same reaction, right? Sodium chloride plus water plus CO2 plus calcium chloride, carbon dioxide. And what will it form? If they were all combined, what would they have formed? They would have formed Na2CO3, that is sodium carbonate plus hydrochloric acid, right? But what difference is there, that we have added ammonia in here. It's almost the same reaction. See, NaCl, sodium chloride plus H2O water plus CO2, but we have added ammonia, NH3. So what do they make? They make ammonium chloride plus sodium hydrogen carbonate. And sodium hydrogen carbonate is what? Baking soda. So they form ammonium chloride plus sodium hydrogen carbonate. How ammonium chloride? It's NH4Cl, right? So it's not very difficult to remember. You just remember this NH3. What is NH3? It's ammonia. So what would ammonium chloride be? Ammonium chloride is nothing but just increase H3 by one more H4, and chloride for Cl. It's the same, chlorine chloride Cl. So NH4Cl, NH4Cl. This is NH3 in the last. So in the after the arrow, the first would be NH4Cl. Here before the arrow, the last one is NH3. So after NH3, right after the arrow, it would be NH4 and then Cl also. You need to remember just this much, sodium hydrogen carbonate. And if you remember its name, it's very easy to remember the formula too. It contains sodium first. So sodium is Na, right? Then it contains hydrogen. Hydrogen goes for H, right? And then it contains carbonate. Carbonate is CO3. Carbon dioxide is CO2 and carbonate is CO3. So sodium hydrogen carbonate means NaHCO3. Right? Just need to remember its chemical name and you will remember its chemical formula by yourself, right? It's not very difficult to remember. You can just recall it very easily if you remember the chemical name. Chemical name sodium. Sodium's chemical formula is Na, right? Then hydrogen H, carbonate CO3. Okay. Did you check the pH of sodium hydrogen carbonate in activity 2.4? Can you correlate why it can be used to neutralize an acid? It is a mild non-corrosive base. So baking soda is a kind of mild base. And when it is heated during cooking, this reaction takes place. When it is heated, when sodium hydrogen carbonate is heated, NaHCO3 is heated, what forms up? It's sodium carbonate. See, Na for sodium, CO3 for carbonate. So sodium sodium carbonate plus H2O is what? Water, plus CO2 is what? Carbon dioxide. So just remember what these chemical formulas denote, and it would be very easy to remember an equation. Now, use of sodium hydrogen carbonate. You can easily just read it by yourself. What is the use of a sodium hydrogen carbonate? Or what is the use of baking powder? Then this is what here. This is sodium hydrogen carbonate again. Plus this is what? Hydrogen ion from any acid. It can be taken from any acid. And what would it give out? It would give carbon dioxide plus water plus sodium salt of an acid. It would give sodium salt of an acid. Carbon dioxide produced during this reaction causes bread or cake to rise, making them soft and spongy. Now you know why baking soda is also used to make breads and all these your kulchas, breads and all these kinds of stuff, then your cakes, because it releases carbon dioxide in the presence of some kind of acid. In the presence of an acid, it reacts with its ions, its hydrogen ions, and it releases carbon dioxide. A little water is also released, and the sodium salt of acid is also released. That's why they're a bit salty sometimes, right? So CO2, this CO2 starts bubbling up inside and rises up, and this causes the small cake to fluff up. It makes it fluffy and soft. It is also used in soda acid fire extinguishers. So sodium hydrogen carbonate is also used in soda acid fire extinguishers. Now washing soda. Washing soda is another important product. Another chemical that can be obtained from sodium chloride, that is your NaCl common salt, is Na2CO3 10H2O. Now this is not at all difficult and this is not at all complex. It's very easy to remember and you can just write it like this. Sodium carbonate. What is this? We already know this is what? Sodium carbonate. Na2 means sodium. CO3 means carbonate. And this, what is this? This is H2O. H2O what? H2O is nothing but water. Why is 10 here? Because it gives 10 times the amount of water, right? 10 times the water molecules. You have seen about that sodium carbonate can be obtained by heating baking soda. Recrystallization of sodium carbonate gives washing soda. So if we recrystallize them, it will give us washing soda, and it is also basic salt. Now this is sodium carbonate. And you what 10 denotes here is that you have to add lots and lots of water. 10 is nothing but the amount of water actually, that you have to add 10 times the amount of water. So Na2CO3, that is sodium carbonate, plus 10 times the amount of water would give what? This is my bad. This is Na2. Na2CO3. And what is Na2CO3? Na2CO3 is nothing but sodium carbonate. Then it will combine with that lots of amount of water. So it will form a compound. Earlier it was separate, but now it has formed a complex. It has formed a compound. So it is one. It is one whole now. And what is this new product? This is washing soda, your washing soda. And then these are the uses of washing soda. So are the crystals of salts really dry? Copper sulfate crystals which seem to be dry, while water which seems to contain water of crystallization. So before we go through this, I think it's better if we read the activity. Here are a few crystals of copper sulfate in a dry heat a few crystals of copper sulfate in a dry boiling tube. What is the color of the copper sulfate after heating? Do you notice water droplets in the boiling tube? Where have these come from? Add 2 to 3 drops of water on the sample of copper sulfate obtained after heating. What do you observe? Is the blue color of copper sulfate restored? I might be having some difficulties to convey properly today because I'm having mouth euplus. So please pardon me for that. So copper sulfate crystals which seem to be dry, which they actually seem to dry when you hold it them your in your hand, or when you look at it at first, at prima facie they look very dry, but they actually contain water, or do they? We'll find it out. Contain water, yeah, they do contain water of crystallization. When we heat the crystals, this water is removed and the salt turns white. So while turning something into crystal, a little water is absorbed by the product, right? And when the crystal is heated up, this water gets released in the form of evaporation, or just simply turns into liquid. This water is removed and this salt turns white. So copper sulfate is also kind of salt. If you moisten the crystals again with water, you will find that the blue color of the crystals reappear, right? It's not a very big deal. It's like you take a sponge, you fill it with water, and you see its color suddenly changes up a bit. Even if it's a yellow sponge or any kind of sponge, it changes a bit in color. That's due to the presence of water. And then when you squeeze all the water out, it changes color back into some kind of dry form. This is what happens with it. Water of crystallization is the fixed number of water molecules present in one formula unit of salt. One formula unit, you can choose any unit as your one formula unit, right? You can take 1 gram, 1 kilogram, 1 milligram. You can choose any particular unit, but then you have to be the same. You have to use the same unit for everything, for every other operation that you do involving that particular case. So water of crystallization, it is the fixed number of water molecules present in one formula unit of salt, present per formula unit of salt. So suppose you do your operations with 1 gram of salt. So water of crystallization is nothing but the water present in 1 gram of salt. 5 water molecules are present in one formula unit of copper sulfate. So in one formula unit of copper sulfate, 5 water molecules are present. Chemical formula for hydrated copper sulfate is CuSO4 5H2O. This represents the amount of water molecules, present one formula unit of salt. Now this, if you wish, you can just check out what formula unit is. What a formula unit is, if you read it on the net, you will be able to get a very thorough idea of what it actually means. I wouldn't be explaining it in here because the video is getting a little bit too long, and I won't be able to post it if it gets too big because of the size limit, right? So these 5 water molecules are present in one formula unit of copper, and previously 10 water molecules were present in one formula unit of what? Sodium carbonate. So this here means that this means that 10 water molecules are present in one formula unit of sodium carbonate. That means it contains too much water. Now chemical formula for hydrated copper sulfate is this: Now you know, now you would be able to answer the question whether the molecule of A is wet on of sodium carbonate is wet, sodium washing soda is wet. One other salt which possesses water of crystallization is gypsum. Okay, we'll read about gypsum and plaster of Paris in the next video. Fine.